Hey guys, it's Miss Redigan here. Okay, so we're going to learn about solubility. So first of all, we learned yesterday that for solids, to make them dissolve faster, you can heat it, you can stir it, you can crush it. So let's go through. You have two beakers here, cool water, hot water. Which one will dissolve faster? The hot one. Next, again, we have two beakers here, one stirring, one non-stirring. Which one will dissolve faster? Okay, stirring. And down here we have, again, two beakers, crushed sugar, a lump of sugar. Which one will dissolve faster? And again, it'll be B in this case. So, heat, stir, crush. For gases, it's the opposite. Gases, in order to keep those bubbles moving slow enough to stay in the solution, you want to cool them and increase the pressure. So keep it nice and icy and keep that lid on. You can see how the pressure is pushing the gas particles to stay in the solution. We also looked at table G. We learned again that gases have a decreasing solubility with increasing temperature. So we have three gases again: HCl, NH3, and SO2. The rest are solids going upwards. Let's learn how to read the solubility table at a given temperature. At 70 degrees, how much NH3, ammonia, will dissolve in 100 grams of water? Remember, the whole graph is based on 100 grams of water, so that's kind of almost like extra information. Let's focus on the details. 70 degrees, NH3. So there's 70 degrees. You go up to the NH3 line, because that's what you're studying. Go over. And approximately 18 degrees, somewhere in there. Right? It's definitely below 20. Let's try another. 50 degrees of KNO3. 50 degrees, and you have to go all the way to the line or the curve that's KNO3 at that temperature. And then you go over to the left. Take a reading. There you go, 85 degrees. Again, looking for the saturation point, the curve. 10 degrees Celsius, KClO3. Let's find 10 degrees and go up to the KClO3. And there it is, 10 degrees meets the curve. And you go over to the left. Okay. Try this one on your own. Find 60 degrees NaNO3. With the temperature, go find the NaNO3 line, go all the way up, and then go over to the left. And there we go. Go to the left, and approximately, you might have had 125 or 127. That's also okay. Okay, another way is to qualitatively talk about solubility. And we can use these words like supersaturated, saturated, unsaturated. If it's somewhere above the curve, we say it's a supersaturated solution. It's holding more than it normally can dissolve. Something super, super sweet, like super sweet tea. Saturated, it's holding all it can. It's completely full. No more, no less. And that's what the line shows us, the curve. Anything below is unsaturated, which is usually dilute or watered down. Let's take a look. Oh, okay. So if this is our substance we're studying, A is above the line and would be supersaturated. B is below the curve or the line and is unsaturated. Let's take a look here. What type of solution is made when 5 grams of SO2 is dissolved in 100 grams of water at 60 degrees? So the key things are you have to find 60 degrees SO2, and then you have to go put a mark at 5 grams. I did. There it is. So is this on the line, above the line, or below the line? And hopefully you answered, it's on the line, right? That dot is meeting the same spot as the line. That makes it completely saturated. Let's try another. Okay, 40 degrees, 25 grams of KClO3. Go put a dot there and then compare it to what normally can hold. So this is the curve we're looking at. We ignore the rest. We go to 40 degrees and 25 grams is where our dot goes. It's 40 degrees, 25, put a dot. Is that dot? Right. Does that make it unsaturated, saturated, or supersaturated? Remember, you're comparing the dot to the line. Hopefully you're saying, oh, it's above, so it's supersaturated. The dot is above the line, making it supersaturated. Let's try another. What type of solution is made when 80 grams of KNO3 is dissolved in 100 grams of water at 48 degrees? So go to 48 degrees and 80 grams and put a dot. Okay. There's your dot. 48 degrees, it's approximate. KNO3 is what we're studying. Compare the line with the dot. And hopefully you're saying, hey, it's on the line. It's saturated. Let's try another. 10 grams of NH3 at 90 degrees. The main thing is the 90 and the 10 grams. Put a dot. Okay, and it's on the line. It's saturated. One more. Again, we're still studying NH3. This time to put a dot at 6 grams, 90 degrees Celsius. Compare. Notice the dot is below the curve, below the line. That makes it unsaturated. Okay, so keep working, keep practicing. Test is Thursday. You can do